Good day, my dear viewers. Welcome again to another Lewin Academy math channel or economics channel where all of your economics or math problems can easily be solved. So today, Lewin Academy will be focusing on logarithms. Now, for most persons, this math problem or this math area can be a little bit challenging. However, after reviewing what I have to do today, then I'm sure that you'll be a pro at logs. Okay, so the topics to cover are laws of logarithm and examples, 3 questions on logarithm. Okay, so law number 1. The first law of logarithm, we say that the log of any number a plus the log of any number b is equal to the log of the number a times b. For example, log 3 plus, so we have here log 3 plus log 5. This will be equal to 3 multiplied by 5, right? And that will be equal to log 15. And bearing in mind that there's an invisible 10 right here, that is why you don't see a number at the bottom, because once it is singular like this, then it means that at invisible 10, base 10. And we count in base 10, so 0, 1, 2, 3, 4, 5, 6, going on, and that's base 10. So that's why you don't really put 10 right there, but it's actually there. Okay, law number 2. Law number 2 states that log a minus log b is equal to log of any number a divided by the log of any number b, right? An example of this is log 6 minus log 3 is equal to log, in brackets, 6 divided by 3, which is equal to log 2, right? Some persons always make a mistake with this because they might see other things and interpret it differently as this, but it's actually not it. Law number 3. Log a raised to the number m is equal to m log a. Now this is a very lovely law, and it saved many of us many times. So they're basically telling you have any number raised to a power, you can simply bring that power to the front of the log, right? And you can proceed with the question. So an example is log 2 to the 4. That is basically equal to 4 log 2, right? Okay. Law number 4. Log 1, the log of 1 with any number is equal to 0, or the log of any number with the same base. So suppose there is a 10 right here, and you know that this is base 10, then it will be equal to 1. Okay? Law number 5. So the log of any number raised to 1 is equal to 0. Law number 5. So, yes, as I was saying before, where you have a 10 right here and a 10 right will be equal to 1 here, is it law number 5. So the log of any number raised to the base and the number is the same, then that number will be equal to 1. So for example, the log of 7 raised to 7, that is equal to 1. Law number 6. Log b, any number b raised to a, is equal to log c raised to a. Now, this is known as the change of base formula. And I want you to pay close attention to this. The change of base formula. So, for example, suppose the original question had a log of 3, right? But you want to change that base to 4 because your calculator cannot do it, right? Then what you do is you put the 4, so the log 4, and then you put a, so which was this, so you put a, 5, and then you put the log 4 divided by that, which is 3, and then you have a new base, right? So that's how it is done. Laws of logarithm continued. Law number 7, where you have log b of a number, then that number is equal to 1 over log a of b. So an example of this would be log 4 of 3. If you want to put it in a fraction form, then it will be equal to 1 over log 3 to the 4. Okay? Law number 8, log b to A is equal to log B to C. So as long as they have the same base, and this is known as the base, right? The base. Then the base is the same, then you just equate the numbers there. So therefore A will be equal to C. Example, log 9 to 4x is equal to log 9 to 12, right? And therefore the answer will be 4x equal to 12 because they have the same base. So you can just simply equate the answer. Law number 9, well, it's not really a law, but it is very useful in solving logarithm equations. So we have a raised to a power is equal to y, right? Now what this is saying is that you can simply convert this form to a logarithm form, or a logarithm form to this form to solve the problem. So x will be over this side, right? And then you will log it. So you log this, so this will now become the base, and then the y will be there, right? So you basically carry over the a and let the y stay. You let the x stay and you carry over the a. For example, suppose you have a 2 raised to the x of 30 is equal to 32. Yes, we know that this will be 2 to the 5th, but if it was a large number like 1,000 or 1 million, then you could just simply log it. And if you log it, and you say x right here will be equal to base 2 of 32, and then you could put this in your calculator and you will get the figure of 5, right? Okay, so now moving on to 3 questions on logs. Okay, so the first question is log of 10 to x plus 8 is equal to 3, right? Now, as I was saying with the law, remember law number 9, where you had to change, so you had let something be the y, so you had the base, and you had the x and whatever. So how can we solve this? Now you can transfer this to a form, to an exponential form. Yes. So you can transfer this logarithm form to an exponential form, or you can move vice versa. So in this case, we say 10 raised to the power of 3 would be equal to the x value in here, right? Which is x plus 8. If you do that, then 10 raised to 3 is 1,000, which is still equal to x plus 8. And then if you should carry over the 8 and minus it, then we have 992, which is equal to x. And that will be the value of x. Simple, right? Okay. So now we're moving on to question 2. Question 2. Okay, so, and question 2 says that you must express this form of log below into a single log. So you have log base 2 raised to 5 plus log base 2 raised to x plus log base 2 raised to 3. Now the advantage of this question is that all of the logs have the same base, which is good. Now we can move forward. We don't have to change the base, because you cannot do anything with a log if it doesn't have the same base, right? And so log 2, now what would be your first step? Now your first step right here would be that, remember the law which says that any number, once you add them and they have the same base, what you do with their coefficients, you just simply multiply them. So you just say log 2 multiplied by 5 times x, right? Oh, by the way, a minus sign should be right here, not a plus. So yes, so you just simply put the minus sign and you have log 2 raised to 3, right? Okay, now what would be your next step? Now can you go any further with this? Yes, you can. What did the law says? The law says once you have the same bases and it's minus, what we do with the coefficients is that we divide the coefficients, right? So we have log 2 5x divided by 3, right? And now that's the lowest that we could possibly put it at, right? And so that should answer the question. Now moving on to question 3. Question 3 is more simple. Very, very simple. So the log 10, now we're doing an equation. So the log base 10 raised to 2x is equal to log base 10 raised to 21. Now they have the same base. And what did the question say? What did the law says if it's equating? Then you just simply equate its coefficients. That's all. So basically, but to make it more easier, you would want to equate the coefficient. What you could do, what the law said was that if there's a power right here, what they said you could do, bring it to the front. Or the power is at the front, you could bring it to the top. So you bring that power to the front, right? And if you should bring that power to the front, then what you'll be left with is log 10. Remember I said that a log invisible 10 is right here. You'll be left with log 2, right? Equal to log 21, right? And so all you have to do is divide both sides by log 2 to get rid of this log 2. So log 2 divided by log 2, that cancels out. So therefore x is equal to log 21 over log 2. And if you should put that in your calculator, then you will get 4.392. Okay. Now I want you to try some questions on your own. Some questions. So you have question 1. You have write the expression below in its simplest form. Here is it. You have question 2. Here is it. Question 3. You should solve this. And I want you to pause the video, and then I'll be showing you the answers afterwards. So go ahead right now and pause the video. Okay, so thank you for attempting the questions. The answer for the questions is question 1 was 3 over 2. Question 2 is x equals 5, and question 3 is x equals 1. If you did not get these figures, then I ask that you watch over my video, look at the laws, try to apply them as best as possible, or you can email me at easya521brains, easyabrains521@gmail.com, or you can message me on YouTube, or you can go on my Facebook channel, Lowin Academy, and you can also message me, and I can help you with these. Or if you have any other query, you can always talk to me about it. So, but if you got these answers, then good job. Good job. Continue to practice to become perfect. And so that's the end of my presentation. Please like and comment on my video. Please subscribe to my channel, and you can also find me on Facebook, Lowin Academy, and you can always text me and tell me your feedback from the video. You can always comment if the video helped you or not, what improvement you think I should take on, all of that. Until then, thank you for watching. Have a great day. Bye.